All right, now that we've taken a little bit of time and seen some theory on the old whiteboard, it's time for Steve to start putting it all to good use. Let's go ahead and create a generic cable system so that we can start creating cables.
Yeah, so what we're going to do in this lesson is set up a generic, we're going to use Vex to do this, we're going to set up a generic Vex network that basically lets us specify our start position, end position, and that arc value that we saw over in our theory, our V1, V2, and our control point.
Okay.
And then in the next video, we'll basically create 3 versions of that network that have it set up so that we have our first end curve, any middle curves that we have, and our end curve, and we copy them about and use stamping to switch between them. But for now, we're just setting up a generic Vex network.
Okay.
So first thing I'm going to do is branch off from our length curve. Let's find the length curve. And branch off from this scale here with a new delete node. Let's bring this down over here. So currently, if we look at points, we're dealing with the basically number of towers here as represented by the points, and we're dealing with the total length. And I basically want to know the distance between any 2 of the towers, or from the end to one tower, and that's going to be the distance of any one of these segments. They're all even in length. So what I'm going to do, I'm going to delete non-selected points and set the pattern to 0 and 1, so that we get the first 2 points, so we just have one segment there. And you saw over in the theory, we were looking at, I need to see the layers. That was the wrong button.
That was definitely the wrong one. What we need to see, if we can back up enough, is this.
Yeah, that's what we needed to see. Awesome. We mapped the value from 0 to 1. I pushed the wrong button on tablet and cleared some stuff out. It's just like, no! So yeah, we want to get this map value from 0 to 1 onto our curve. And the way we're going to do this is a really nice technique that Peter set up, is to create another line that basically goes from 0 to 1 in translate y and just has 2 points. And he uses the translate y value, basically sets that up so that the v value of UVW coordinates is set to translate y. So you've got the v of the UVW going from 0 to 1 along the curve, and then he basically copies the position of that line onto the position of these points, so that our curve is basically this curve, but with UVs going from 0 to 1. So it was quite a nice workaround that he did there. So let's drop a new line in, and I will call this line cable base. I'll set that all at default values because that gives us a line that goes from 0 to 1 in y. Its direction is positive y and its distance is 1. And we only have the 2 points that we need as well. So points is set to 2. So with that left at default, we're dealing with a polygon line. So let's wire this into a vertex node to deal with vertex attributes. We'll come down to texture and change that over to add texture. And where we've got $mapv being the current v part of the UVW, we're actually going to replace that with $ty so that the translate y value of the point is used in there. So now we've got mapv going from 0 to 1 along that line. So what we're going to do, we're going to wire this guy into an attribute promote, because currently it's a vertex attribute and I'd like to promote it up to a point attribute so that we're dealing with points, because we're going to deal with points later. So the original class is vertex, the original name was UV, and the new class is going to be point. Now the promotion method shouldn't really affect anything here because it's used when you have more than like a 1-to-1 mapping, but here we have 2 points being mapped onto we're having 3 parameters being mapped on from vertices to points. Vertices match up to points 1-to-1 mapping, as opposed to, say you were going from point to primitive or vertex to primitive and you have more vertices than you do primitives. You need to say, well, are we going to take the average value or how are we going to deal with it? So I'm actually just going to set promotion method to maximum, but it doesn't really affect anything here because we have the same number of vertices as we do points. Everyone has a 1-to-1 mapping and we don't need to do any averaging of values or anything. So with that, we can wire this into a point node and start dealing with these point attributes. So let's take this guy into input 1 and wire our delete into input 2. And we've got this line set up with our value going from 0 to 1 that we wanted, but currently he's in the wrong position. He's in that position and we want him to match this guy. So what we can do, we can take our translate values and basically set all of them so that every point is set to the translate value of the second inputs point. So with that set up, we can now start dealing with the detail that's going to be on this curve. So we can wire this guy into a resample. And I'm checking maximum segment length and checking max segments. So let's set up a parameter on our master control to control this, since it's something you may wish to control. So let's edit the parameter interface, drop down a new integer, and let's have a think. I'll put this below braces again, above tiers, and we'll call this cable divisions. So, whoa, crazy typing. Cable divisions, which I will lock at 1, since we want to have at least 1 division there, and I'll give that a range on the slider up to 30, but we'll leave it unlocked. So let's accept that and find our cable divisions there, copy that guy, and use that to drive our segments here. So as we start boosting up cable divisions, we'll get more and more points. I'll set that to something like 20. The more points, the more detail we're going to have when we have a fully skinned tube surface, and that will be in a couple of videos' time that we'll actually see that. So we can now wire this guy into an attribute create node. What we're going to do, we're going to take our true height parameter that's on the master control and basically add that as an attribute on the curve so that we can quickly and easily get to it down in the Vex network. So let's drop this into an attribute create node. We'll call this attribute height, and we'll set the value for that to master control's true height, which is currently 3.79. So we are dealing with, it's a primitive, we don't need to have it per point since it is a single value. It's going to be the same for everybody. So we know we're going to be setting up a generic Vex network. We're going to basically set it up so we have a start position, an end position, and an arc amount that's going to allow us to control our curve. So let's wire this guy into a VOP-SOP. It's a very quick way for setting up a Vex network that affects surface geometry. It basically creates a Vex network that becomes a new surface operator. So we can pass in our curve into the first input, and inside we can now basically set up a Vex network that works on the geometry we're passing in. Currently we only have outputs. This is going to be basically defining what's output from the output of our VOP-SOP node.
Right.
We need to get our geometry in. And to do that, since we use the first input on the VOP-SOP, we can use a global variables node. The global variables node will pull in information from that first input. And we've got the position of the point coming in from there. So in X and in Z, the positions of the points aren't going to be changed. We're only going to be dealing with Y when we're changing this curve up. So we can wire the position from the global variables into a vector to float, which allows us to split it into the 3 components. We can drop down a float to vector, wire that into the output position, and basically take X and Z straight across. So now we need to basically bring in our UV attribute that we created earlier. So we can do that by dropping down a parameter, and we just jumped, that's fine. So I'm going to rename this to UV val, give it the parameter name we're after. It needs to be UV because that's the same parameter name we used earlier. We're basically going to look to see if this is bound to our object being passed in. I'll call that UV val. It's not a float, it's actually 3 floats in a vector. And we're going to check the use input parameter if parameter not bound. What that does is it gives us an ability to input a value, and what will happen is this parameter UV, it would be basically checking our first input to see is UV bound to this object. If it does, if it exists, if it can find it on the point or whatever, it will use that value and output it from here. However, if it doesn't exist, if it can't find it bound, it will use whatever's passed into the input. If there's no input, it will use a default value that's set up. So we know it is bound, so we should just be getting the value that's coming from our line that's being passed in.
Okay.
So we don't want to deal with UV and W, we just want to deal with the V channel because that's the one we mapped our Y to. So I've wired that into a vector to float to split it up into the 3 components. And also let's add some parameters that we will be controlling externally. We basically refer to our start and end points. So let's drop down a parameter called value A. And this will be a float. It will be val A, and the label will be value A. And we'll do the exact same thing for value B. And the label is value B. Just jumping down here, I'm actually going to change up the range for both of these, give us a bit more range. So if we were to jump up and look at our VopSop, we can see value A and value B have been created as parameters on that. So with that we can actually jump back down into that. And from here we can start basically implementing the maths that we saw over here. So we've got a value A, basically value 1, and value B. So we need to take our value that goes from 0 to 1, which is t here, take value B and multiply that together. And we need to add that to 1 minus t, 1 minus our value that's mapped onto the curve, multiplied by value A. That's the first thing that we'll get set up in the Vex network. So let's actually maximize this up. So let's take our value B that's coming in, we want to multiply that by t, so we can wire value B into a new multiply node. And our t value was our value we basically mapped to the V channel of our UVW. So we can take our value 2 and wire that into our multiply node. So that was this part, our t times V2.
Hang on 1 second, let me do this for you. There you go. Now point to it so
Sweet.
you can see.
This is our t times V2.
Okay.
So now let's set up our 1 minus t for V1, for value A. And so obviously we need to take this value here and have 1 minus that value. So we can drop in a constant node, tap P to bring up parameters on that, and set the value to 1. It just needs to be an integer. Set the integer value to 1. I'll just call this a constant 1. So we can wire this into a new subtract node. And in fact, we are going to need to set this guy to a float because of the way the subtract works. I need 1 minus something. If we were to wire an integer in, it wouldn't let us subtract a floating point from that. So if we wire in a float, it will allow us to subtract 1 from this guy. But if we set this guy over to an integer, this then throws up all errors and stuff. So let's set that back to a float. So the output of this guy is going to be 1 minus t, which we want to multiply by our value A, our value 1 that's coming in. So we can grab this value A, wire that into a multiply. We can grab the 1 minus t into the other part of the multiply. And we saw over here we're simply adding those together. So we can take the output of this guy and wire that into an addition. And take the output of this guy into an addition, so add those together. And then take the result of this and use it to drive the Y value on our curve. Now currently, it looks like it has no effect there. The reason for this, the reason for this is because of our value A, that was 1 level too high. Our value A and value B are currently set to 0. If we were to bring value B up and bring our visibility down here, so that's controlling the endpoint of our curve, so that's a linear straight line there. And value A is controlling the start point of our curve. So with that in place, there's actually a couple more things that I want to take into account, even for this simple part of the network. And that is that I want to take into account our height parameter that we stamped on, our true height, so that if we're changing the the true height of our towers, we're going to be changing the height of our cables as well. And so because of that, let's bring in our height parameter and tap P. So let's call this height. And the parameter name, we added the attribute onto the curve, so we want to use the exact same name. That exact name is height, and the label can be height. And again, we'll check the use input value if parameter not bound. But the parameter should be bound from when we created the attribute. So actually didn't want to minimize that, never mind. So we can now take this guy and basically take it into account in both of our multiply nodes. So we can wire this into the first multiply and also wire that into the second multiply, and as long as it found the parameter, that's okay. I thought that might have happened when I changed that to primitive instead of point. I guess because we're dealing with points down in Vex, it doesn't like that being a primitive attribute. That did click in my mind originally when I changed it. I thought it might explode, but I'd see if it would work, and it didn't. So changing this back to point means that our parameter is being picked up fine here as it comes in. So it's basically acting as a scale on our values A and B, so that if we were to find our master control and change any of the things that affect true height, like for example the overall height, that's also going to affect our cables. Jumping back into the Vex network, we also want to basically take into account our arc. So because of that, we can basically set up another parameter like value A and value B. So let's drop in a new parameter, which I will call arc value. And if we tap P to bring up some parameters, it's going to be a float. It's going to be arc value, and I'll change that range to -2 to 2. So now if we were to jump up a level, we'll see that we have a arc value parameter here. So let's use that to take that into account with our equations. So if we come back to Photoshop, we're now dealing with this last part of the equation where we've got our controlling arc value. So we need to take both 1 minus t and t itself, multiply those together with that value and add it back into all the others, which is really easy now that we've got everything flowing here in Vex. So we can simply take our t value, which is our value 2 from the UV, and middle mouse click to branch off into a multiply. We can take our 1 minus that value into another input on that multiply. We can take our height value into the input, since we want to take that into account as well, and our arc value that's coming in. And we can wire that into our add to add them all together, so that if we were to come over to our parameters on our VOPSOP, we've currently got value A and value B controlling the height of the curve. If we were to start bringing in our arc, it starts giving us a control over the arc on our cables. Nice. So, with that, that's actually set up our generic cable rig. Everything down in Vex, our generic Vex network. So that concludes this lesson. Awesome. Thank you very much.